alcohols, phenols, and ethers. So alcohol means that is it is represented by ROH or OH. And phenols, as I already mentioned, that is represented by C double bond OH. C double bond, then COH. This is called enol. So when it is a phenyl enol, it becomes a phenol. Phenyl group is 5, that is C6H5. For example, when I put C6H5, then it is called a phenyl enol, that is phenol. So this is a enolic functional group, whereas alcohol is simply OH that is attached to saturated carbon atom that bears no double bond. So that makes the difference. So alcohol means what? It is attached to saturated carbon atom, whereas enol means hydroxyl derivative that is attached to what? Unsaturated carbon atom. So that makes the difference. And ether means this is an oxy linkage. So this is called ether. For example, dimethyl ether. This is called oxy linkage in the case of ether. So we have now, for example, let me take an aromatic alcohol. So this is CH2OH. Take down CH2OH. But when it is straight away joined, then it is called phenol. So this is phenol, whereas this is benzyl alcohol. Okay, benzyl alcohol. This is phenol. Then you have got phenoxymethane or methoxy, that is phenyl mether ether also, that is a methoxy benzene. For example, you have benzene ring where you can attach the two oxy group through CH3. So in that case, this should be called methoxy benzene. Okay. So it means as far as ether is concerned, we have a mixed type of ether. On one side, you have got aromatic compound, another is aliphatic. So it is a mixed type of ether. So in ether, we have a pure ether like a CH3CO, CH3O, CH3, dimethyl ether, or it can be called a methoxymethane. If you have got CH3, CH2, then OCH3, then it should be called you may think that it can be called a methoxyethane or ethoxymethane, but ethoxymethane is wrong because according to IUPAC rule, you should have long chain hydrocarbon. So this is the long chain compared to the methyl group. So it should be called ethane. So this is called methoxy. So this oxy link is attached to the that is a lower level bulky group only. Okay. So if you have got propane and you have got meth, so it should be called a methoxypropane, right? Now let me write one structure. You try to identify the nomenclature. CH3, CH3, CH2, CH2, O, CH2, CH3. What do you call this compound? This is the longest chain, that is propane. So it can be called ethoxypropane. Okay. So ethoxypropane is the IUPOC nomenclature for this. I hope now you should be able to understand this very clearly. Pranav, are you able to follow this? So I have given a general introduction about the various types of molecules here. I mean the alcohols, phenols, and the ethers. Okay. And here you can notice here that is RO means that is the aliphatic, RO aliphatic ether. ARO means aromatic ether. Okay, so what is this aliphatic ether? What is this aromatic ether? If it is ROAR, AR means aromatic. So this is a mixed type of ether. Okay. Then now the classification of alcohol. Alcohol can be classified based on the number of hydroxyl group. In this case, you have got monohydrate. So when you have got only one OH, it is called monohydrate. When you've got two OH, it is called dihydrate. When you've got three OH, it is called a trihydrate. For example, this is called glycerin. Okay, so what do you call it? Glycerin or glycerol. And this is called ethylene glycol. And this is ethanol. Okay, so what is the epoch nomenclature for this one? If two hydroxyl groups are repeated, then it can be called a diol. So 1,2-ethane diol. 1,2-ethane diol. And what about this triol? So 1,2,3 triol, but it is based on propane. So propane 1,2,3 triol. Likewise, you can give the nomenclature very easy, right? And similarly, you've got sorbitol also, which has a six number of covalents. Okay, right. Now we have another classification like a compound containing CsP3OH bond. What do you mean by this? CsP3 means that is this carbon is sp3 hybridized. It means it has got only saturated carbon atom. So in that case, this CH2OH, this is the general representation of primary alcohols or CH2OH, where R starts from hydrogen itself. If it is hydrogen, this is methanol. If it is a CH3, then it becomes CH3, CH2OH, that is ethanol. So likewise, you can build up. And you have the primary alcohol, that is RCH2OH. Secondary alcohol will be R CH again R. Okay, so this is called secondary alcohol. This is primary, this is secondary. Okay, so where you can find, for example, this is the function group. OH group is the function group, right? So this OH group is attached to alpha carbon atom where you have got two hydrogen. So in the case of primary alcohol, you have got two hydrogen. And that is why it's called primary alcohol. If you don't have two hydrogen, instead if you have got only one hydrogen, then it is called secondary alcohol. If there is no hydrogen at all, it means they are connected to three alkyl group like R. It can be CH3, CH3, CH3 also, or it can be a varying one CH3, CH2, CH3, C2H5 like okay. So I will give you some example way to give the name of this compound. So I have CH2, CH3. This is CH3. This is CH3 and then OH. Now what do you call this compound? You must be able to identify the longest chain. First of all, you can definitely say this hydroxyl group is attached to carbon atom that is free from hydrogen. So this is tertiary alcohol and you can have a longest chain like this. So and take the lowest substitution. So 1, 2, 3, 4 means butanol where you got 2-methyl. So 2-methyl, 2-butanol. That's all. So what is the nomenclature? 2, you have to write like this 2-methyl and then put 2 and again butanol. Otherwise, you can call it 2-methyl butanol. Butanol. Okay. Then similarly, we have primary, secondary, and tertiary. In the case of sp3, CsP3OH bond. Okay. Now let us move to the next type, that is allylic alcohol. So what is this allylic? Let me explain about this allylic. You've got two types of group. One is allyl group, another is vinyl group. Okay. So allyl group means allyl and vinyl. Let me explain both. Allyl alcohol is, for instance, when you got a compound like this, for instance, CH2 double bond CH single bond CH2. This group is called allyl group. Vinyl group is CH2 double bond CH single bond. So this is called allyl group. This is known as vinyl group. Okay. And similarly, you have another type of group that is called benzyl. For instance, you have this benzene structure, and this is CH2 bond. So this is known as benzyl group. So likewise, that is, you've got three different types of groups in the sp3 hybridized, but it is routed through CH double bond. So in this case, now listen to me. Here, CH2 double bond CH. You can look at this. CH2 double bond CH single bond CH2 then OH. And this is called allylic alcohol. That is allyl alcohol. This group is called allyl group, and the alcohol based on that can be called allyl alcohol. So that is why it is generalized as allylic group. And you got this CH2, where you can have this is a primary alcohol. Is it not? Why it is primary alcohol? Yes. Now, can you identify the unsaturation between which two carbon atoms can you say? For example, let me consider this CH2. Let us consider CH2, double bond CH, single bond CH2, and this is OH. Now, first of all, you should be able to identify whether it is primary, secondary, tertiary. Whether it is primary or secondary, tertiary. Why? Because yes, this is the function group. Identify like this. This is function group. What is this alpha? What is this beta? What is this gamma? Now, the unsaturation occurs between gamma and beta. Got this point? So, such type of alcohols are called allylic type, allylic alcohol, because this group is called allyl group, and the alcohol based on that can be allylic alcohol. And now you can replace these hydrogen by that is one H or another alkyl group like that. So you can make it secondary also. How? By introducing another alkyl group. Okay, for example, I can make it like this: CH2 double bond CH single bond CH, and here I can put some alkyl group. You can put it CH3 and then OH. And what do you call it? This is the allylic group with the primary functionality. This is the same allylic alcohol with secondary functionality. Do you understand why it is secondary? Because you have got only CH. Now, can you develop a tertiary allylic alcohol? How can you develop? You have, yes, for instance, allylic. So you have that is CH2 double bond CH single bond C, put CH3, another CH3. Got it? Now simply OH. So this alpha carbon atom is free from any hydrogen atom. So this is tertiary, right? And what about this? This is alpha means this is beta, this is gamma. Okay. So you should be aware of this type of compounds also. So these are classified under allylic alcohol. So what are the three types of allylic alcohol we have? Primary allylic, secondary allylic, tertiary allylic. Got it? So just by looking at the structure, you should be able to classify the type also. Okay. And what about the previous one? That is the sp3 OH based one. And this is also sp3 based one, but you have got the unsaturation between beta and gamma. Okay. With all that, we have got this kind of a benzylic alcohol also. This is called benzyl alcohol. For instance, you have this is benzene. You have got this is methane. What is the molecular formula of benzene? C6H6. What is the molecular formula of methane? You know very well, CH4. So, less one hydrogen atom. Less one hydrogen atom. It is called what? That is CH3. Then you call it methyl group. Then you add OH group. You are able to get methyl alcohol. That is methanol or methyl alcohol by trivial name. Okay, but in this case, you cannot say C6H5, this is benzene, and C6H5 is benzyl. No, C6H5 CH2 alone is benzyl. And what about this? This is phenol. So this should be called a phenyl. And okay, when you attach OH to this, what will you get? Will you get a phenyl alcohol? Wrong, because we already know the hydroxyl group attached to unsaturated carbon atom should be called enol, not alcohol. That is totally a different thing. Okay, do you understand this now? So C6H5 and then OH. So that should be called the phenol. Do you understand this? Okay, right. Then, um, so we have already discussed about this allylic type. I mean, vinylic type. Vinylic type is CH2 double bond CHOH. This is called vinylic alcohol. Okay, vinylic alcohol. But this is a kind of is a type of enol also. Why? Because carbon atom is attached to double bond. It is an unsaturated carbon atom. The same thing is available in the case of phenol. See this? Okay. When I put like this, you know very well this carbon atom bearing double bond and that is attached to OH. Got this point? And what about this C? This is sp2 hybridized and here also sp2 hybridized. Okay. Then, and regarding phenol, you've got some substituted phenol, like you may be having a phenol like this, though this is called phenol, but when it is, it can have multiple hydroxyl groups also. For example, you've got one, this is monohydrate phenol. What about this? This is called dihydrate phenol. What about this? This is called trihydrate phenol. Okay, like that. So mono, di, tri. Okay, so you can draw differently. And as far as the ethers are concerned, you have got the symmetric ether and unsymmetric ether also. Okay, so now are you able to follow? If there is any doubt, you can ask me in the telegram. Right? Sure. Okay. And here, let me consider about the ether. So the ether, you have CH3, O, CH3. What is this? Dimethyl ether, or it can be called methoxymethane, right? Now, if you've got, say, C2H5 and O, then CH3. This is not symmetric. So, this can be called unsymmetric ether. So, what is this? Unsymmetric ether. What about this? This is symmetric ether. Okay. Now, uh, let me consider C4H9 OH. This is butyl alcohol. Okay, this is butyl alcohol, right? And let me introduce C2H5O, C2H5. What is the formula? What do you call this compound? Diethyl ether. You've got ethyl, and this is also ethyl. You can call it diethyl ether or ethoxyethane. Okay, what is that? Right, ethoxyethane. Now, I have one formula. See, you can add this, you can add this H here. So C4H10O. So develop various types of ether, that is isomers of ether of C4H10O, right? Can you develop? How you can develop? Let us take one. Now first cut CH3 from this. C4H10O. Subtract CH3. What you will get? What is the remaining? C3H7. So you can develop one ether. What is that ether? That is CH3O C3H7. Correct? C4H10O. So minus CH3. So it means C3 and H7. O is there. But I am just taking only the leave the O group. Or if you want to take, you can take. Because it is already aligned as oxy group. Okay. So this is CH3O C3 itself, right? So what do you call this one? Methoxypropane. Okay, so we are able to develop one ether. Second ether, how can you write? Write down C4H10O and now subtract instead of CH3, subtract C2H5. Okay, and separate O, that is a function group. Now what is that? Again, you will get C2H5. Okay, so in that case, you can get C2H5, O, C2H5. So what is this ether? Ethoxy ether, diethyl ether, right? Diethyl ether. Now, can you identify one more ether from this compound? Can anyone try? There is one more ether. Pranav, can you try? You have got one more ether here. Try that.
So we see
No, your this is ether of the ether. You can develop one more ether also. What is that? You can have one more ether. For example, C3H7. That can be taken as the isopropyl. So it means C3H7 can be built up like this. Okay. CH3, CH3. So this is CH, okay? And then put O, then CH3. Got it? You cannot. So CH3 twice CH, then OC. So what is this? This is an isopropyl group. So you can call it methyl isopropyl ether. That is the common name. And what is the IUPAC name? This is the methoxy group, and this is the longest chain, 2-methoxypropane. Right. So this is called 2-methoxypropane. Okay. Okay. Then now let us proceed with the another type. I hope now you've got certain questions. You can just try. Classify the following primary, secondary as a tertiary. What do you call this alcohol? Primary, secondary, tertiary. It looks like tertiary, but it's not tertiary. It is primary because you have to focus on. Okay, so you have to be very careful. So likewise, you can try the other things also. Now let us move to the nomenclature part of it. So as far as the names are concerned, you have um, methyl alcohol. You know this basic prefixes in hydrocarbons. Meth, then eth, then prop, etc. You know all these things. Okay. Now let us have C5 H. What is the R formula? Alkyl group CN H2N plus 1. So if it is C5, C how much? 11, H11. And then what? OH. Okay. So this is nothing but penta. So pentyl alcohol. So pentanol. Okay. Right. You can have various types of pentyl alcohol by classifying its branches like primary, secondary, tertiary. So, can anyone develop tertiary based on pentanol? How to write down? C. Tertiary means three branches with one OH, with no hydrogen atom left. So you can put the remaining one. So you've got already C, 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 C. So you can extend one more so that you will be able to get what is the 5. Now you can put the hydrogen atom, make sure each carbon atom has a valency 4. So you got already one, so you can put 3. You got already one, so you can put, so tetravalent carbon should be maintained. 1, 2, 3, 4. So it has no hydrogen atom. In this case, CH2 you can put here CH3. So CH3, CH2 and C where CH3 twice. So this can be written in the linear form like this CH3, CH2 and you can put CH3 twice C and then OH. Okay, so you should be able to understand this also. Okay, so this can be written like this. And what do you call it? Take the longest chain. So the longest chain is a 3 propanol. So 2, this is 1. This is 1 only. How you can say 2? It is butanol, correct. Four. You can take four now. One, two, three, four. So 2-methyl, 2-butanol. Right. 2-methyl, 2-butanol. Write down. 2-methyl, 2-butanol. Okay. And you can have another structure like a neopentanol. Take down neopentanol, pentyl alcohol. So this is nothing but the carbon atom is surrounded by four carbon atom and put OH, right? So this is CH3, 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 and CH2. Now tell me whether it is primary, secondary, tertiary, primary only because CH2OH. But apparently it looks like tertiary. Okay, so what do you call this compound? Neopentyl alcohol. What is by IUPOC? 1, 2, 3, propanol, dimethyl, 2, 2 dimethyl, 1 propanol. Okay. And let us proceed with now iso. Let me ask you one simple question. Isopropyl alcohol and isobutyl alcohol. So this is a secondary, this is a primary. Why? Can anyone explain? Listen here. Let us take up this one. Isopropyl. Isopropyl means what? Iso, twice branched, similarly branched, and with the three carbon atom, put OH. And what about isobutyl? Four carbon atoms. So with the three symmetric one and put C and then put OH. So here you can put CH3, CH3, here CH. Whereas here CH3, CH3, H and H2. So this is secondary, this is primary because CHOH, this is CH2OH. Okay, then. So you should be able to explain like this, right? Then I was explaining about the ethylene glycol and glycerol. How to call this ethylene glycol? 1,2-ethane diol or ethane 1,2-diol. How? You've got CH2OH, CH2OH. Okay, this is first carbon atom, this is second carbon atom, and this is OH. So we have got two OH, so it will be called diol. And it is attached to first and the second carbon atom. So it can be called 1,2-ethane diol. Okay, you have to write ethane, then diol. Then what is the IUPAC name of glycerol? CH2, CH, CH2OH. Can anyone tell me? This is called glycerol. And what is the IUPAC name? Propane triol. So propane 1, 2, 3 triol. What is it? Propane 1, 2, 3 triol. You can call it propane 1, 2, 3 triol. Now, can you identify the type of hydroxyl group, alcohol, primary, secondary, tertiary? What about the first? This is first carbon atom, second carbon atom, third carbon atom. First one primary, second one secondary, primary. That's it. Okay, very good. Now, Uh, let me introduce the structure of, glucose and try to identify the primary, secondary, if there is any tertiary alcoholic functionalities. Like this is called, that is 1, 2, 3, 4, 5, 6. Okay, so CH, OH, H, OH, OH, H, H. This is called glucose. Take down. You know very well C6H12 O6. Since it has got aldehyde, potential aldehyde, and since it has got six carbon atoms, and generally sugar molecules are called O's. So, a sugar molecule with the six carbon atom and one potential aldehyde group can be called aldo, that is potential aldehyde. Six carbon atom, that is hexo, O's, sugar. So, it's called aldohexose, right? Now you have to identify the type of hydroxyl group. Okay, can you try? What type of alcoholic group it is? This one, this one, secondary, this one, this one, this one. Very good. So you can expect that when this glucose is subjected to some chemical reaction like oxidation, it will answer for secondary alcohol as well as the primary alcohol. Okay. So based on the product, you can easily elucidate the structure of glucose. So that is one of the very important studies in uh, biomolecules. We call it the structural elucidation. Then now, so likewise, you've got various nomenclatures. So please go through that, and let us talk about these. Um, that is alicyclic compounds. Alicyclic means aliphatic but cyclic. For example, we can start with the cyclopropane, but this is not stable. And this is cyclobutane because it has got four carbon atoms. And this is called cyclopentane, which has got five carbon atoms. And this is known as hexane, so cyclohexane. Okay, but actually, cyclohexane will be having a boot form like this, of course, which is less stable, but you've got another chair form also like this. So these are called cyclohexane. And if there is any alcohol, then it can be called cyclohexanol. So can you get the formula for cyclohexanol? Simply you put like this and put OH. That's all. Okay, cyclohexanol. Let me ask you one important question. What's the difference between, have you noted down? What is the difference between phenol and cyclohexanol? Phenol is this one. Cyclohexanol is this one. Now get me the first of all the molecular formula. What is that? Pranav, can you tell me? This one. C6, right? After all, you got C, 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 C. Then you got hydrogen, 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 hydrogen. Just count the hydrogen. And instead of one hydrogen, you got one OH. Now tell me, there are six C6, then H5. Is it not? Then OH. Okay. So this is called a phenol. And what about this? In each carbon atom, you have two hydrogen. Okay, please note down. So it means CH2, CH2, so CH2, 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 and then here you have got one more H, and instead of one H, you have got OH. Now tell me the molecular formula. Very good. C6H. Uh, why it cannot be C6H12? So C6H11. Okay, that's great. Okay. Now, so when since we come across this kind of cycloalkanes, now there is a relationship between alkene and cycloalkane. Can anyone tell me this? There is a relationship between alkene and cycloalkane. Both of them have CnH2n formula. This is also having CnH2n formula. For example, Let me consider, can you tell me any alkane with, say, about six carbon atoms? CnH2n, let us work out. C6H12. So that is a hexene. And you can have cyclohexane also. For example, in the case of cycle, so let us classify this. This is alkene, and this one is cycloalkane, right? So here let us work out 1, 2, 3, 4, 5, 6. Put double bond and put CH3, CH2, 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 then CH and then CH2. Correct? So you please check it up. It gives you what? One hexene, right? And you can also get two hexene by dislocating the double bond. Three hexene like that. But in the case of cyclohexane, you've got cyclic ring structure like this. Then CH2, 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 right? Okay. In each carbon atom, you can find, since these CH2 are totally accumulated, it cannot have a plain structure like in the case of benzene. So it has got some steric strain, and that is why it adopts what, chaff form or both form. Okay. See, you can imagine, for example, let me show you. This is the, I can show you like this. Let me take one part only so that you can understand the other part. So this is the hexane pattern. Okay. Similarly, you've got this hexane pattern also. Let me take the smallest one. Okay. So this is a hexagon. You can take this as a hexagon. Now, what happens is, can you get me that molecule structure, molecule model? Take that. So we have one, two, and three, fourth one. So you have like this. Another is, okay. Okay. So let us imagine this one part. Okay. And I have to join one more part. Now you just look at this. This is the hexagon. Are you able to follow? Now, if you leave like this is not a planar one. Immediately, you see, it forms a boat form like this. And in fact, there is one will go like this. Okay, it will go like this. Are you able to follow? So instead of having the plain structure, it goes like this. And the another one, so this is the parallel line. Okay, see this? We expect a hexagon like this. But because of the strain, because each carbon atom will be having two hydrogen, so it doesn't have enough space to accommodate these hydrogen, two hydrogen in each carbon atom. So what happens is one is lifted like this, okay? And if both are lifted like this, it forms a boat form. Are you able to follow this? Right? And suppose one is here, and here also there will be a strain. So what happens? This, instead of having two angular bond like this, one will go down. So it will form a structure like this. So this one and a boat form like this. Okay, I mean chair form. So this can be drawn in a better way. See, that is, instead of having a regular hexagon pattern, we expect the hexagon pattern like this. Okay. Instead, what happens? It forms a boat form like this, two upward. Okay. Let me indicate by one, two, three, four, five, six. So first carbon atoms, fourth carbon atom, they go out of the plane on the same place. Now, there also it has got some strain. So what happens? One goes upward, one, and the fourth one will come downward. Four. I hope now you should be able to understand that. In order to have better stability, it forms such a type of chair form. So this is called chair form, this is called boat form, and this is ruled out because of the strain, right? But in the case of that is why it is not coplanar like benzene. Do you understand? So cyclohexane cannot be attaining the coplanarity. It cannot lie on the same. Okay, why? Because each carbon atom has two hydrogen atoms. Okay, right. So I hope I was able to explain nicely this concept. Then let us move to the next one. So we were discussing about the various types, and see, this is called the dihydrochol phenol can be called catechol. This is known as catechol, 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 and it can be called the benzene 1,2-diol also. Similarly, and this is the orthodihydric phenol. Okay, what is that? Orthodihydric phenol. Orthodihydric phenol, and that is orthodihydroxy derivative of benzene, that is catechol, and this is the resource node, that is meta position. Okay, and what about the other one? This is in the para position. This is known as hydroquinone or quinol. Okay, hydroquinone or, so draw all these structures. So these are all the three different types of derivatives of um, dihydroxy derivatives of, that is phenol. Then we have got the ether. I think I already explained about this. And we have got the various types of ether. You just look at this one. What is this? C6H5O CH2 CH3. So this is called phenatone. So it means that is one benzene group is there. It is ethoxy. So ethoxy benzene is called phenatone. So similarly, you got mixed ether that is called anazole. Anazole means methyl phenyl ether or methoxy benzene. So take down this one also. So C6H5OCH3 means what? Anazole. That is methoxy benzene. And what is a phenatone? That is ethoxy benzene, right? So similarly, you have got different nomenclature. You please go through that, and you know already about this phenyl iso. I already explained about the iso compounds also. Now you just go through the in-text questions also. That is very important. And if you don't know, you please discuss with me. Then I will try to explain about the structural aspects. That is the structural aspects of alcohol. So here you've got that this COH. You can have this bent structure, so its angle is 108 degree 9. 108.9 degree. Can you convert this into minute? You know very well 60 minutes is equal to 1 degree. Okay, 60 minutes is equal to 1 degree. So 1 degree is equal to 60 minutes means you've got zero point 0.9 degree. Okay, what you're supposed to do, zero point 0.9 into 60. So it means 54. Is it not? So 54 minutes. So you can call it 108 degree, 54 minutes. So likewise, you can write down the bond angles in minutes also. Okay, right. Then, so here the you got the CH. So this is a methyl alcohol, and the bond distance here it is given as that is picometer, and it is called picometer 142 pm. Pm means picometer 10 power minus 12. That is equal to 1 picometer. Okay, so you can call it 142 into 10 power 12 minus 12 meter. So that is the bond distance. And you can find this bond distance is 96 picometer. Okay, so it means that there is a distance in the bond distance, difference in the bond distance. For example, this is 142, this is 96. Okay, and moreover, this bond is this carbon is sp3 hybridized. Okay, this bond is sp3 hybridized. But in the case of phenol, you can simultaneously draw the structure phenol. So in the case of phenol, see that C6H5 OH, where you have got O, and this is the double bond, alternate double bond. It's also called conjugated double bond. Now look at the that is a phenyl ring and oxygen bond distance. The bond distance is 136 picometer. Okay. In the previous case, it was 142 between CH3 and O. Here 136. So that should be noted. And not only that, and here the bond angle of OH is 109 degree. So here 109 degree. This is the phenyl group OH bond angle is 109 degree. Okay. But so this is almost resembling to alcohols only. This is 108 zero point 0.9 degree and this is 109 degree. So the methyl group bond OH. Similarly, phenyl group bond OH. So both the bond angles are almost closer to 108 degree or 109 degree. Okay, right? But when you consider, listen to me very carefully, when you consider the same oxy link between the methoxymethane, for example, you've got methyl group, O, methyl group. When you consider this bond angle, it is much greater than this. It is 111.7 degree. Okay, 111.7 degree. So you can say the bond angle, in which case the bond angle is less. And you know about the bond angle in tetrahedral structure also. What is the bond angle in tetrahedral structure in methane? You got 1, 2, 3, and that's methane. 109 degree, 28 minutes. Do you understand? In case of methane, the bond angle is 109 degree, 28 minutes. And here, in the case of bond angle, it is roughly that is 109 degree, 28 minutes. So this is the CHO here. Okay. Whereas in the case of methane, I mean ether, in the case of ether, it is 111.7 degree. And also that is in this case, the bond angle is 142. Here it has come down to 136 and here it has almost a closer value to alkane, alkanol, alcohol that is 141. So when you consider the CO bond and between the bond length, you can find there is a contraction. Here it has come down to 136. So what is the key point behind this, it indicates that there is some affinity here. It is more tightly bound to the wall, the phenyl group. Okay. Then now there are some key points to be discussed here. You please note down. The bond angle in alcohol slightly less, as you have mentioned, than in the tetrahedral structure. It is due to what? The repulsion between the unshared pair of electrons in oxygen. So there is a repulsion between unshared pair. What do you understand from this? Let us consider this structure. Okay. Now see, that is when you go through the textbook, by just by reading the textbook, you may not be able to understand. You have to take the pen and try to illustrate the things what is given here, so that you should be able to understand something from this text. You should have a better comprehension here. Now, listen to me. They were talking about this C and then O and then H. So this is the bond angle they are talking about. Okay. So here I was, I think I already released about the Lewis structure, but you had to go through that, where you have got two lone pairs of electron like this for oxygen. They have got the repulsion tendency that is according to the VSPR theory, that is a valency pair repulsion theory. And because of this, there is a change in the bond angle. Do you understand this point? So there is a repulsion between the unshared. Unshared pair means this is the unshared pair that cannot also be called a lone pair. Okay. So there is a repulsion between the unshared pairs of what? Oxygen, where in alcohol. But in the case of phenol, you just look at it in OH group, that is phenol. That is attached to sp2 hybridized carbon atom, and here the carbon oxygen bond length is 136 picometer in phenol, that is slightly less than that in the methanol. So it may be due to what? The partial double bond character. Okay, take down. Partial CC double bond character. Okay, in on account of the conjugation of unshared pair of oxygen. So it means what you understood from this. For example, you got alternate double bond here. That is called conjugation. So this bond pair of electrons can come over here, and that can involve in delocalization of pi orbital, and that is why it is shorter. The bond length is shorter here. Okay, so so this is one of the important structural studies about the alcohols and phenols. Then in the next class, I'll be explaining about the preparation of alcohol. And I would suggest that is you better uh, draw the clock diagram. So for preparation, clock diagram means put the alcohol here. When you want to discuss RCH2OH, put like this and put various methods inward. Okay. And here you can write what are the reagents and reactants, and you can write the reaction conditions here. So put 1, 2, 3, 4 likewise. So you can make it as a chart, and this is called the clock diagram of preparation of alcohol. So likewise for every type of alcohol or every compound you can have like this. And for reactions, you can put the arrow mark out also, where you will be writing the product out. Okay, so here input, output is at the center. In the case of properties, the output is available in the peripheral clock diagrams. Okay, so we'll continue the next class. Okay. So if there is any doubt, you can discuss with me. Any doubt? Please go through our previous videos also, so that it should be useful to you.